In this seminar, we are going to talk about character arrays and how we can work with them using pointers. When we talk about character arrays in C, we want to talk about strings. I'm sure you already know about strings, but to be able to work with a string efficiently in C, there are a couple of things we need to understand. The first thing that we need to understand is how we store strings in character arrays. This is one way to declare them, where the beginning of the array is at some location in computer memory, for example location 1000. It's really important to notice that one character is needed to store the null character, \0, which indicates the end of the strings. A character array can have more characters than the string held in it. If we had an array like this, the array would look like this, where 3 array elements are currently unused. A disadvantage of creating strings using the character array syntax is that you must stay ahead of time how many characters the array may hold. For example, in the following array declarations, we state the number of characters, either implicitly or explicitly, to be allocated for the array. Thus, you must specify the maximum number of characters you will ever need to store in an array. This type of allocation, where the size of the array is determined at compile time, is called static allocation. Of accessing a contiguous chunk of memory instead of with an array is with a pointer. However, pointers only hold an address. They cannot hold all the characters in a character array. This means that when we use a char pointer to keep track of a string, the character array containing a string must already exist, having been either statically or dynamically allocated. Below is how you may use a character pointer to keep track of a string. We will have something like the following in the memory, supposing that the array label started at memory 2000. Also, to assign the address of an array to a pointer, we do not use the address of operator, since the name of an array, like label, in this case, behaves like the address of the array in this context. That's also why you don't use the ampersand when you pass a string variable to scanf. Parsing strings to function is really interesting. Below is the definition of a function that prints a label and a call to that function. Since label is a character array and the function printLabel expects a character array, this makes sense. However, if we have a pointer to a character array label, as in here, we can also pass that pointer to a function, as in here, and the result will be the same. Why? Well, when we declare an array as a parameter to a function, we really just get a pointer. So, printLabel could have been written in these two ways. Parsing strings to function is really interesting. Below is the definition of a function that prints a label and a call to that function. Since label is a character array and the function printLabel expects a character array, this makes sense. However, if we have a pointer to a character array label, as in here, we can also pass that pointer to a function, as in here, and the result will be the same. Why? Well, when we declare an array as a parameter to a function, we really just get a pointer. So, printLabel could have been written in these two ways. There is no difference because in both cases the parameter is really a pointer. The C library string.h has several common functions for dealing with strings. These are some common useful ones. The use of most of these functions is very straightforward. For example, if we had two declarations like this, and we call the function string copy, we will copy the string 1 to the string 2. Note that both strcat and strcopy both returns a pointer to the first character in the destination array. The strcomp function lexically compares the two input string and returns less than 0 if string 1 is lexically less than string 2, 0 if string 1 and string 2 are lexically equal, or greater than 0 if string 1 is lexically greater than string 2. The strcat, strcomp, and strcopy functions are string restrictive versions of their more general counterparts. They perform a similar task but only up to the first n characters. Something important. Note that the null terminator requirement may get violated when using these functions. An example will be this. If we had these two declarations and we call the function strcopy, with this form strcopy, string 2 may not be null terminated. There are very useful searching functions too. These are one of them. String chart and string chart. When we execute these functions, after the execution, ans points to the location str1 plus 2. strpbrk is a more general function that searches for the first occurrence of any group of characters. For example, when we call the function here and we are searching for LO, we will just answer str plus 3. There are other useful functions in another libraries like ctype.h. These functions contain useful functions to convert and test single characters. The common functions are prototyped as follows. The use of these functions is straightforward, and we will not give examples for this. Well, that's it, guys.